Hey, what up, guys? It's Nick the Quant, and today we've got another post for today's highest mathematical edge pick. Yesterday, I gave you guys the Pittsburgh Pirates on the money line. Unfortunately, they lost in, I think it was like the 11th inning to the Giants, so pretty brutal there. So this puts us on a three-game skid, which betting on singular outcomes, this can happen, especially if you're EV betting, but the big thing is just thinking of this in a long-term time horizon. If the probabilities are correct and you're making decisions that have positive expected value, the whole point of that is once the sample size becomes large enough, and this becomes tens to hundreds plus of bets, and you're constantly doing the same process over and over. The results you'll have in the long run will then be a reflection of what that expected value is of the bets you place. As the probabilities, once sample size increases, start performing where they should be at the mean of their distributions. So saying that, these highest mathematical edge picks right now have a record of now 4-5. So we're 4-2, 3 games down, 4-5, and we're still a little bit profitable at plus 0.33 units. So saying that though, today's gonna be a dub. We're gonna jump into today's pick right now. Today I got the San Francisco Giants on the money line, who the Pirates lost to yesterday. Got them on the money line at plus 159. My model has them at a 45.43% probability against the Dodgers. So while my model isn't giving them the mathematical favor, my model is viewing them as being significantly undervalued relative to their odds at plus 159, denoting significant financial advantage when placing a bet on the Giants side relative to the Dodgers side. This is proven by the fact that the Giants have plus 17.66% expected value, and I will be risking 1.85% on the Giants using that sixth of a Kelly criterion, which I'm still keeping stable due to pretty lackluster performance, really all MLB season, to put it slightly. My model has been having a hard time, but before I go into this further, I think what's interesting, and I talk more about this, I'd say, on my X account when I get into insight on my model and what's going on. My model, like I've mentioned in my past videos, it had 3 layers of calibration. The interior models were calibrated, and then there was a calibration done in that initial ensemble output, and then you would implement the market region for a 3rd layer of calibration. I think what was happening, because this approach is different than when I did college basketball, and college basketball was very successful. I think the difference is the 2nd layer of calibration. And what I mean by that is in college basketball, I used empirical calibration on my interior models, meaning once you have a large enough sample size, you can start to trust calibration being around the actual real world results of those probability predictions. But I was using calibration that would take into account, and I'm talking about baseball now. I was using calibration that would take into account both the model output and then the real world outcomes. And the problem with that is, while that, like in theory, that is absolutely what you should be doing, but the problem with that is if the sample size of a specific probability is relatively small, the calibration is going to rely more on the model's output, which can be pretty abstract because you don't actually know what that specific probabilistic prediction is relative to its correlation with real world outcomes. So what I mean is, if a model says 55% probability and that only hits 45% of the time, but your sample size is small, you could use a confidence interval, for example, to see, okay, like where's the lower, mean, and upper bound of that. But the point is you don't really know yet, because the sample size is small, what the true honest probability of that specific probability is as far as the model initially outputting it. So my problem is that the calibration both on the 1st layer and the 2nd layer, but the 1st layer mainly, was taking too much into account for the initial model outputs and not putting enough emphasis into what their actual real world performances are. So then you bring in 2nd layer calibration, which is being done on that initial output. You're almost essentially doubling down in a way, or double calibrating on the outputs of models rather than the honesty of models. And I think as I was doing model diagnostics for hours yesterday, I kept doing different scenarios. If I calculated probabilities in different ways, and I kept finding that the worst performance was when I was implementing 2nd layer calibration, drastically worse performance, and performance got better when I moved to empirical calibration rather than the calibration I was using at this point in the season. So this is the change I'll be making because I can't just keep doing the same thing over and over, right? This is all about learning. The cool thing with empirical calibration is, my model, I try to flood it with data. Daily, I do data accumulation for my MLB model, and then I'm currently in the process of training my college football model. So I'm daily feeding my model data. So a model can never have too much data. So when you use empirical calibration, that is the goal when you want to get to, for real accurate calibration. Empirical is obviously the best because you're basing it on reality, but you need to have a large enough sample to actually trust that, because swings of variance shouldn't drastically change the actual empirical outcomes, should I say. So just wanted to kind of spew into that. But anyways, we're going to get into this Giants pick. So as you guys know, my ensemble model has 9 inner models, and now they're being calibrated on the empirical outcomes up to this point in the season. So saying that, Model 1, the Dodgers fell in a position that currently has an 85% win rate on the season. So Model 1 has the Dodgers at an 85%. Model 2, the Dodgers fell into a 60.61% win rate. So Model 2 has the Dodgers at a 60.61. Model 3 has the Dodgers at a 54.45. At this point, you can kind of see where these probabilities are coming from. Model 4 has the Dodgers at a 71.43. Model 5 on the Dodgers at a 57.89. Model 6 had the Dodgers at a 48.04. So Model 6 actually has the Dodgers place in Model 6 in an area that is a pretty contrarian position, especially against favorites who the model initially favors very strongly. Their outcomes have been largely negative, as denoted by that 48.04. Model 7 has the Dodgers at a 55.45. Model 8 has the Dodgers and the Giants at a coin flip 50-50 each. And then Model 9 has the Giants at a 58.82. It's a strong performing position right there. So saying that all spits out the Dodgers being, or should I say in this case, that spits out the Giants being a 45.43% probability, as they're the side with that positive expected value. So now this is typically where I would bring in that second layer of calibration, but right now, because I'm going over empirical, I have to recollect data now on the ensemble outputs. So second layer calibration will come back into play eventually, but I need to collect data on how these actual ensemble outputs are performing using empirical calibration. So we're still going to implement, though, the market region calibration, which is where I'm getting right now. So the Dodgers aligned themselves today in a market region that up to this point in the season is a pretty contrarian position, has only a 47.73% win rate. So when accounting for that, with that initial Dodgers probability output, which was a 58.22%, that brings the Dodgers down and the Giants up to that final position where the Giants are a 45.43% probability. So the Giants clearly have the value here. Again, these results, or this calculation, is based off of each individual model that was ran based on the real world results of the initial predicted probability. So the Dodgers at Model 1, initially the Dodgers were, I think, somewhere in the 70s, but that probability has been hitting 85% of the time. So Model 1, Dodgers 85. This is what I used for college basketball, and I was up almost 30 units on the season. I was just at 28. But that model was nowhere near as robust as the layout of this model. So I'm really excited to move forward going this way. So let's get back on track. Let's get a dub today on a high value Giants pick. And before I close out this video, as always, to get access to all of my free sports betting plays, you can go on my X account at NickTheQuant44 or my Instagram account, NickTheQuant, where I post my day results and then my daily highest mathematical edge picks, and that come to the YouTube blast. But if you want all of my picks rather than just this singular pick, which I do highly recommend, my X account, I post all the picks immediately when my model runs on them. So yeah, thank you.